Hello everyone, today I am here to talk about a critical cybersecurity threat that affects web applications and databases worldwide: SQL injection. And I am very much excited to share insights into this dangerous attack vector and discuss measures to safeguard our data. Let's get started. So, first of all, we will talk about what is SQL injection. Basically, SQL injection is a type of cybersecurity attack where malicious actors exploit vulnerabilities in web applications by inserting malicious SQL code into input fields. And these attacks target the application's underlying database, enabling the attacker to access, modify, or delete sensitive data. SQL injection is one of the most common and devastating web application vulnerabilities. Now, we will talk about how does SQL injection works. So basically, SQL injection works by exploiting vulnerabilities in a web application's code that allows an attacker to manipulate the SQL queries which are sent to the underlying database. And here is a step-by-step explanation of how SQL injection attack works. So the first point is user input. Web applications often take the user input through forms or URL parameters which are used to construct SQL queries to interact with the database. For example, a login form may ask for a username and password. Then secondly, lack of input validation. Insecure web applications may fail to validate or sanitize the user input properly. So instead of validating the input, they directly incorporate the user's supplied data into the SQL query. Then third is injecting malicious code. So an attacker takes advantage of the lack of input validation to insert malicious SQL code into the input fields. And this code is usually crafted to manipulate the SQL query's logic and achieve unintended results, altering the query. The attacker adds SQL commands to the user input to alter the original SQL query structure. So for instance, they can append additional conditions to the where clause or inject a union statement to merge data from multiple tables. Fifth is running malicious queries. The manipulated SQL query is then sent to the database server by the web application. Unaware that it contains malicious code, the database server executes the modified query, effectively giving the attacker unauthorized access to the database. And the last one is unauthorized access. So depending on the attacker's intent and the vulnerability severity, SQL injection can lead to unauthorized data retrieval, data modification, or even complete control over the database. Now we will talk about how the SQL injection attack occurs. So SQL injection attack occurs when an attacker injects malicious code into a web application's input fields. This code is then executed by the database server, which can lead to a variety of security vulnerabilities such as unauthorized access to sensitive data, data modification, or even complete compromise of the database. So now I will tell you what SQL injection can do. It can gain unauthorized access to sensitive data. It can also change or delete data in the database. It can even execute arbitrary commands on the database server. It can deface the web application, and it can even take control of the web application. So SQL injection attacks can be very much dangerous, and it can have a significant impact on the web application. That is why it is so much important to take steps to protect your web applications from SQL injection attacks. Furthermore, we will talk about some of the harmful actions that a SQL injection attack can accomplish. So we will start with unauthorized data access. So the attackers can bypass authentication mechanisms and they can gain access to sensitive data such as user credentials, personal information, financial records, and intellectual property. Then comes data manipulation. The attackers can modify or delete data in the database, leading to data corruption, loss of critical information, or even tampering with the integrity of the application. Then the other one is account takeover. So SQL injection can be used to hijack user accounts, granting attackers unauthorized privileges within the application and potentially compromising multiple users. Then complete application compromise. So in severe cases, attackers can take control of the entire application, gaining administrative privileges and causing service disruptions or website defacement. Then comes elevation of privileges. So SQL injection can enable the attackers to elevate their privileges within the application, accessing features or functionality that they are not authorized to use. Then comes planting malware. So the attackers can use SQL injection to insert malicious code into the application's database, which when executed could lead to further exploitation or serve as a foothold for other attacks. Then comes exposure of sensitive source code. So SQL injection can reveal the underlying application's source code, which exposes potential vulnerabilities that could be exploited further. Then there is denial of service. DOS attackers can perform SQL injection attacks to overload the database server, leading to denial of service for legitimate users and causing service interruptions. And the last one is data leakage. So the sensitive data might be leaked either by displaying unintended information in the application's response or even by taking advantage of error messages to reveal details about the database schema or query structure. Okay, so now we will talk about one of the examples to better understand SQL injection. So for example, let's say that a web application has a form that allows users to search for records in a database, and the form has a text field where the user can enter the search criteria. So if the web application is vulnerable to SQL injection, an attacker could enter malicious code into the search criteria field. And this malicious code could then be executed by the database server, which would basically allow the attacker to gain unauthorized access to the database. Now I'm just giving you one more example that an attacker could enter malicious code into a form field that is used to update a record in the database. And this could allow the attacker to change the data in the database or even delete the. So these were a few of the examples from which you can understand how an SQL injection works. Now we will discuss about the SQL injection in different parts of the query. So mostly the SQL injection vulnerabilities arise within the where clause of a select query, but it can also arise on the other locations. So the most common locations where SQL injection arises are: the first one is in the update statements. Within the updated values or the where clause, in an update statement, the updated values or the where clause can be vulnerable to SQL injection attacks. For example, when an attacker could inject malicious code into the updated values to change the data in the database, or they could inject code into the where clause to change the results of the update statement. Then comes in insert statements within the inserted values. So in an insert statement, the inserted values can be vulnerable to SQL injection attacks. For example, that an attacker could inject malicious code into the inserted values to add malicious data to the database. Then comes the InSelect statement within the table or column name. So in these statements, the table or column name can be vulnerable to SQL injection attacks. For example, an attacker could inject malicious code into the table or column name to access data that they are not supposed to have access to. And the last one is in select statement within the order by clause. So in a select statement, the order by clause can be vulnerable to SQL injection attack. For example, an attacker could inject malicious code into the order by clause to order the results in a way that reveals the sensitive information. Moving forward, here is an example of how Union SQL injection attack works. So basically, Union SQL injection is a type of SQL injection attack that uses a union operator to combine the results of two or more select statements. And this can be used to extract sensitive information from a database, such as usernames, passwords, and credit card numbers. So for example, let's say that you are visiting a website that allows you to search for products. The website has a search bar where you can enter the name of the product. The website then queries the database to find all products that match the search criteria. So this query would combine the results of the search query with the results of the select statement that queries the user's table. And the results of the query would be returned to the attacker, including the usernames and passwords of all the users. So Union SQL injection can be a very much serious security vulnerability. It can be used to steal sensitive information from a database, which could then be used to commit the identity theft or any other crimes. Now we will be talking about second-order SQL injection. So before talking about second-order SQL injection, let's talk about first-order. So basically first-order SQL injection arises where the application takes user input from an HTTP request. And in the course of processing that request, it incorporates the input into a SQL query in an unsafe way. So in the second-order SQL injection, which is also known as stored SQL injection, the application takes the user input from an HTTP request and stores it for future use. And this is usually done by placing the input into a database, but no vulnerability arises at the point where the data is stored. Later on, when handling a different HTTP request, the application retrieves the stored data and incorporates it into a SQL query in an unsafe way. So second-order SQL injection often arises in situations where the developers are aware of SQL injection vulnerabilities and so safely handle the initial placement of the input into the database. And when the data is later processed, it is deemed to be safe since it was previously placed into the database safely. At this point, the data is handled in an unsafe way because the developer wrongly deems it to be trusted. Moving on, we will be talking about the types of SQL injection attacks. So these attacks can be classified into various types based on the techniques that are used by the attackers and the way they exploit vulnerabilities in web applications. And here are some common types of SQL injection. Number 1 being classic SQL injection. This is the most basic type of SQL injection where an attacker injects malicious SQL code directly into the input fields to manipulate the query's logic. It typically occurs when the web application fails to validate and sanitize user input. The second type is blind SQL injection. So in this attack, the attacker exploits a vulnerability that doesn't display SQL errors or responses directly. Instead, the attacker makes the application perform conditional operations, and based on the application's response, the attacker can infer if the injected SQL query is executed successfully or not. The third type is time-based blind SQL injection. So, this is a variation of blind SQL injection. Here the attacker injects malicious SQL code that introduces delays in the application's time taken to receive a response. The attacker can infer if the injected query was successful or not. The fourth one is error-based SQL injection. In this, the attacker intentionally triggers SQL errors in the application to extract information about the database structure or data. The error messages generated by the database are then used to get insights into the database schema or contents. The fifth one is union-based SQL injection. So in this, the attackers inject a crafted union statement to fetch data from other database tables which may not be accessible through the original query. The sixth one is out-of-band SQL injection. This could be achieved by triggering DNS requests or making HTTP requests to an external server which is controlled by the attacker. And the last type is second-order SQL injection. So when the payload is processed, it might lead to SQL injection vulnerabilities in other parts of the application. It is very essential to understand that these types of SQL injection attacks to effectively protect web applications and database from potential threat, implementing secure coding practices, input validation, and using parameterized query can significantly reduce the risk of SQL injection, and regular security audits and testing are also crucial to identifying and mitigating vulnerabilities in a timely manner. Now moving on, we will talk about some of the real-life consequences. So the impact of SQL injection attacks can be catastrophic, and some real-life consequences includes data breaches, sensitive user data such as passwords, person information and financial records can be exposed, or financial losses where businesses can suffer significant financial losses due to compromised customer data and reputational change. Then comes application takeover, where attackers can gain full control over an application, leading to service disruptions or data manipulation. Then legal and compliance issues, so companies might face lawsuits and regulatory penalties for failing to protect the user data. Talking about the risk factors of SQL injection, number 1 being the using user input in SQL queries. So this is the most common way that SQL injection attacks are carried out, and when user input is used in SQL queries, it is very much important to validate the input to ensure that it does not contain any malicious code. The second point is using unparameterized queries. So unparameterized queries are those queries that are not properly prepared before they are executed, and this can make it easier for the attackers to inject malicious code into the queries. Then comes using outdated software. So basically, outdated software may contain vulnerabilities that can be exploited by the attackers. Hence, it is very much important to keep software up to date to help protect against these vulnerabilities. Then comes poor coding practices. So poor coding practices can make web applications more vulnerable to SQL injection attacks. For example, using insecure functions or not properly sanitizing user input can increase the risk of an attack. And the last point is insufficient input validation. So input validation is the process of checking user input for malicious content, and if input validation is not done properly, then it can allow the attackers to inject malicious code into the web applications. By understanding the risk factors of SQL injection, you can help to protect your web application from these attacks. Now talking about the examples. So in the first case scenario, we have an SQL select ID first name last name from authors. If one provided first name is EvilX and last name is Newman, then the query string becomes select ID first name last name from authors, where first name is equals to EvilX and last name is equals to Newman, which the database attempts to run as incorrect syntax near ill as the database tries to execute evil. So a safe version of the above SQL statement could be coded in Java as shown in the slide. So, here in the next example, it examines the effect of a different malicious value passed to the query constructed and executed in example 1. So if an attacker with the username hacker enters the string name delete from items -- for item name, then the query becomes the following two queries, which is shown in the picture. The SQL statement delete from items -- is an example of a potentially harmful SQL injection attempt. In SQL, the delete from statement is basically used to remove reports from a database table. The items in the context is likely the name of a table that stores items data in the database. So the actual SQL query that would be executed in just delete from items, the -- and everything after it are treated as comments and have no effect on the execution of the query. However, if this SQL injection attempt were successful, it could delete all the records from the item table in the database, resulting in a significant data loss. In a database where comments are not allowed to be used in this way, the general attack could still using a trick similar to the one shown in example 1, and if an attacker enters the string name delete from items semicolon select \* from items where is equals to a, then delete from items. This is a delete SQL statement that would typically remove all records from the item table in the database. Deleting all the records from a table without any condition can be a destructive action leading to our data loss, and select * from items where is equals to a. So this is a select SQL statement that retrieves all rows from the items table where the condition is equals to is true. However, this condition is equals to a will always be true since it is equal to a. Therefore, this select statement will fetch all records from the items table. The entire example, when put together, attempts to perform two actions. The first action is it will delete all records from the items table, and the second one is it will retrieve all records from the item table. Then in conclusion, SQL injection remains a persistent threat to web applications and databases. Understanding the techniques used by the attackers in implementing robust security measures can protect us from this devastating cyber attack. Thank you for your attention. I hope you have learned